Hello, everyone. Thank you for coming to today's webinar, Addressing the Impact of Tariffs Using Operational Excellence Tools and Effective Problem Solving. Your presenter today is Mike Papinas. Mike is an Omnex consultant with expertise in manufacturing operations, Six Sigma, lean manufacturing, and process improvement. He has created and implemented lean standards and training for Ford Motor Company in 30 plants across the Asia Pacific and North America. Mike has trained management and employees at Ford and suppliers, focusing on various methods to reduce costs and improve quality. He was co-awarded a patent for the development of a computer-integrated methodology using lean manufacturing methods and Six Sigma techniques for the identification of bottleneck operations and waste in manufacturing operations. Mike holds a bachelor's degree of science in mechanical engineering from the University of Michigan and is a certified Six Sigma black belt. If you have any questions throughout the webinar, I kindly ask that you type them in the chat box and we will address as many as we can at the end of the webinar. Now, without further ado, please welcome Mike Papinas.
Thank you, Kelsey, and welcome everyone. Good morning to everyone, and thanks for making this webinar this morning. I am Mike Papinas, and I will be sharing with you some of what we at Omnex think are some important tools and very accessible tools for you to use to address the issue of tariffs, which we all have been very well aware of, and how they are very volatile and what that really means to us in our operations and what we can actually do to address basically reducing our costs to address these tariffs, right? And we're talking about today are some very useful and effective and powerful tools that really come from different areas of lean, Six Sigma, operations excellence, and coming together to really, in a focused manner, address some of the places that we can make some improvements in our operations to address these incremental costs that are pretty much out of our control. So we're going to be talking about some of those things that we can use, some of those tools, and thinking about how we could follow some kind of a logical path and how we can apply these things. And so what we're seeing here is something we like to think of the path, our path to cost savings to address the tariffs. And starting with very fundamental thing over here on the bottom left-hand side of the screen, and kind of making our way across the arc to ultimately getting to continuing to reduce our costs and stay competitive and ultimately stay in business. As first off, let's establish goals and see what we need to improve. And then from that, know how to improve. And that's what we're going to be talking a bit about today. How to improve, what tools, what methods, what sequence in which to use those, what are some benefits from those things. And then, of course, making those actual improvements, leading towards what we feel very strongly about it at Omnex is a standard common approach in our operations to sustain those improvements, right? And when we think about these things, now looking at the bottom of the arc here, yeah, it involves engaging our leadership in that team effort at our operations, defining our current state, coming up with those improvement projects that know how to improve and making those actual improvements, leading ultimately to locking in those improvements in standard practices. So yes, this is our path. And what are we talking about specifically? Right to it. Impact of tariffs, right? What's not in our control? I mean, you may have seen these in the press. Here's what the targeted tariffs were, a few weeks ago. I think they probably have changed some, but essentially, directionally, this is what we're saying. By country, here's what the targets are for increasing our costs. I think everyone recognizes that these are costs that we are going to bear as operations in manufacturing enterprises, right? So what does this mean to us? What's not in our control as a result of these tariffs? Well, this is just a few over here listed. We know for certain, we're already seeing it. Supply chain instability, the uncertainty in that. Part shortages, production schedule impacts, quality concerns. Where are we going to go to get our parts? Are we going to go, try to qualify new suppliers for this? Indirect costs. We'll see some of those listed out as well. Reducing, the customer orders being reduced, labor shortage increases, the total cost from the cost of the tariffs that really hits our bottom line. We don't really, because of this, have a lot of control over these things. So if this is not in our control, what really is? Well, the things that we see every day in the four walls of our operations. Equipment availability, making sure our equipment is maintained, making sure that changeover times are taking the least amount of time to change over from one product line to another product line, schedule changes, volume changes, changeover times, mean times to repair. That's something that we can, with our workforce, address immediately to reduce those mean times to repair. Cycle time losses, an element of machine wellness. Are we meeting our cycle times? And then not to overlook measurement systems, right? And really conducting our gauge R&Rs, ensuring that when we're making quality decisions with measurement devices, that we're making the right decisions based on their condition. So equipment availability, it really is about making sure, so we're going to talk about OEE today, and making sure that equipment is available. We're using our available time as best as possible. When we're running, we are running at cycle time. And when we are running at quality. What else? On the right-hand side, we're talking about work groups. Who's going to help us accomplish this? Well, our work groups through continuous improvement actions, workplace organization, and cleanliness. That's a long way of saying 5S. And we're going to talk about that today too. And of course, team-based problem solving, one of the most effective and continuous improvement efforts are always around team-based problem solving, looking at what truly is value added versus non-value added work. So these are the things that we see at Omnex, are things that we can do, activities that we as operations people, supervisors, superintendents, managers, directors, maintenance, production, quality, IT, HR, can all be a part of to address essentially reducing our costs. How? Looking at these wastes. This is again a little bit of a mixture today, discussion around Lean, Six Sigma, and operation excellence. Here are the wastes. These are the things that we can go after. And in the Lean world, these are pretty well known. Motion, conveyance, corrective actions, inventory, waiting. This is our cycle time issues. Black, starved, overprocessing, overproduction, addressing those wastes. Oh yeah, and there's one more. The team-based, our employees, our workforce, putting their experience and knowledge to make improvements and reduce waste and associated costs. Here they are. These are the fundamental costs around the cost of poor quality, right? Internal costs. I'm just going to pick off a few of these things that we are well aware of. Things like scrap, downtime, redesign, right? When we talk about corrective action reports, or we're putting in change notices, engineering, ECRs, ECNs, redesign. That's time, that's cost, that's impacting our bottom line. If we're going to be addressing tariffs that are not in our control, these are the kinds of things that we can go after. Let me just look at defects. Once again, internal costs, scrap, rework. Here, defects, of course, scrap, rework. Maintenance. We're going to talk a little bit about maintenance today. Total productive maintenance specifically. Inventory. Stuff just sitting around waiting to be paid for by our customer. That's waste. And then when we're not making our rates, things like premium freight, air or truck, however you're getting it. Cost of poor quality, we've got control over that because we can control our own operations. It's about processes that are not in proper control, not in even perhaps statistical control, looking at parts per million and yield as some of our base measurements that we can correlate back to those costs we saw earlier. So when we're talking about what we really have in our control is what are we doing about our wastes? Those wastes that are in our operations. Again, motion, conveyance, inventory, overprocessing, cycle time losses, the use of our workforce to make improvements, how those all impact those costs. So again, shown here again on the right. It is a fact that the highest quality producer is also the lowest cost producer. Why? Because they are addressing these wastes and they are controlling these costs as a result. So, what are you thinking about? What are you measuring for this? We talked about just a moment ago, just mentioned parts per million, but what numbers, just as an example, what do y'all talk about when you're talking about your measures addressing, go back for a moment, addressing these wastes? Think about that. What are you focused on the customer? Are you focused on quality? What is quality for y'all, right? What is the quality? How are you measuring that? What are the drivers for those qualities, those quality measures, right? Are they across your organization? Are they common, right? Are you taking into account variation and how it impacts your quality? Quality is cost. If you don't have it, your costs will be higher. And so I'm not going to walk through all these either, but just suggestion, metrics across those elements, people, man, machine, materials, methods. Yeah, there's a lot of metrics out there. Which ones are you actually focused in on that are making a difference in your costs? And are they aligned with each other as you go across departments? So, yeah, we're talking about wastes measured by costs associated with those wastes, and then metrics to try to control those things. Are those all aligned, right? Are those things aligned so that there are not competing or conflicting metrics across departments? Here at Amex, we do work a lot with aligning businesses' metrics to ensure that the entire enterprise is working cohesively towards a total cost reduction model, right? So just as example here, making sure that across quality, safety, cost, people, maintenance, and environment, do we have the right metrics? Are we measuring the right things to ensure that this system is all working together? And this is where Operation Excellence really kind of helps us bring some logical approach with some very easily accessible tools that are effective and efficient. When we talk around Operation Excellence and we think about Lean and Six Sigma and those elements of Operation Excellence, we really think along the lines of what do we do for improvements in the physical? What do we do for improvements in the way we do work, the operational side of things? And of course, the impact and the influence of those things on culture and vice versa, the culture within the four walls of that operation on the others. So these are the things that really make up operational excellence considerations when we're talking about what are we really focusing in on here. Today, ultimately, this is what we're going to talk about, these 6 items, these particular tools to help get those wastes identified, reduced, and put into control with continual improvement. Some of the very basic tools to get our operating costs down. First thing we're going to talk about, value stream mapping, how that helps us identify things. 5S, engaging the workforce to help the operations make improvements, see improvements, and solve problems. Total productive maintenance. Next step in the sequence of what do we do across the operations to start to make or improve our machine availability. Then we're using a metric of overall equipment effectiveness. We'll talk about that and how that's going to help keep us on track and make those improvements. And then one of the elements within there, which again is within our control, changeover, quick changeovers, sometimes known as single-minute exchange of dies if you're in the forming world. But there are other elements, of course, that quick changeover can apply to other elements of manufacturing. We're going to talk about that. And finally, item number 6 here, problem solving, effective problem solving across the hierarchy of the organization, from work teams on the production floor up through engineering. Some very powerful, easily accessible tools to solve problems, because we need to be good problem solvers. If we are going to be number one, looking at our value streams, we're going to look for opportunities to make improvements. There'll be issues we'll need to resolve. 5S, we'll find issues that we'll need to resolve. Total productive maintenance. Yes, we'll find issues there that need resolution. Same with overall equipment effectiveness and quick change. So we need, as an enterprise, as an organization, we need to be good at problem solving. So we're going to talk about some of the more basic problem-solving tools like 5Y and 8D, very common methodology for solving problems. So let's talk about value stream mapping. Item number one, it's a graphical process for being able to see our operations, being able to take into account cycle times, downtimes, quality rates, value added time, non-value added times, to give us a complete operational view of how things flow, and using very common basic symbology and some very common and basic definitions around things like value. What is value? Clear definition of value shown here is whenever you're changing fit, form, function of your product, that is a value-added operation. Things that the customer will pay for. I think there's somewhat of a pretty common understanding of that. Everything else is considered waste. Yeah, front office transactional processes that are not affecting directly fit, form, function. If you're not changing fit, form, function, it's not value added. It's work that value added is work that the customer feels that they are willing to pay for. Everything else is stuff that they won't pay for. This is our definition and how we can now look at our operations and say, what is important? What is not as important? What is not as important? All right, so value stream mapping helps us go from what we see on the left here, perhaps to a more structured, more relatively easy flow. It applies and looks at the use of lean principles to, again, get at the sources of waste. And how do we do it? Well, grab some paper, grab a pencil, go to the back of the shop, walk towards the front, walk upstream against the flow to start to create your map so you can see things flowing at you. People ask, well, why don't you just go from the beginning to the end? Well, because you'll get caught up in the flow and you won't see as clearly as when you go against the flow, right? So value stream mapping, yeah, grab a pencil, start to write some boxes, start in shipping, move your way up towards, if it's packaging, if you got a press room, up into whatever the operations are, go from the back of the building to the front. Start to build a map. Here's an example map with these basic symbols, right? What's an operation? It's a box. Tell me, I'm starting back here in shipping. What goes on there? They've got shipping. What's before that? Paint. Before that, they got some kind of weld, then some forming, punching, and then shearing. Here's the operations. Collect data, cycle time, changeover times, uptime, quality rates. What is the times for down, cycle time losses, quality losses? These things add up. And using some common symbology, you can, as along the bottom here, you can start to now see how much time is actually spent in the actual operations as a part. Consider, though, yourself as a part, right? Flowing through the system. How much time is actually spent with changing fit, form, function versus look at your inventory in between those operations. That's what each one of these diamonds are. How much time are parts sitting around waiting for the next downstream operation to actually do something to it, to change its fit, form, function? Add those two different elements together, you'll see that, as we show here, here's the total lead time. If you add all these times and seconds together across this particular exercise, it says 37.4 days for a part to get through here. In this example, parts to make it through the inventory piles just to get to the next operation to have some kind of change, fit, form, function, versus the production time, 180 seconds. Where are we going to focus our attention? Where are those operations that are the bottlenecks? How do we control? This is at the top of a value stream map. How do we actually call for parts, control the flow of parts? How do we forecast the production schedule, overlaying how it actually flows? Value stream mapping gives us a complete picture. And, us at Omnex, we can show you how these things work. We can work with you to develop these. Walk your plant floor from the back to the front. Collect the data. If there's inventory, how many pieces? What are the cycle times? Collect all this information. You have it in one snapshot. Value stream maps give us the baseline for making and seeing improvements. So here, real quick, we have some steps. I should mention too, this webinar will be available for you to pull down later because we are going to move through this material relatively quickly. So you can always come back and take a look at this. But steps to complete a value stream map, start at the back. Draw every supplier that you might see around there. Boxes for the operations, fill in those, get those data, fill them in. Keep walking upwards. Make changes as you make more, learn more information about your particular operation to operation. Add the business processes over top. Start to get line efficiencies, and then you can then calculate some of the cycle time and takt times and so on. This is a good map in itself to building a value stream map. Value stream maps give us the picture of where we should focus our efforts. Where are the constraints? Where are the bottlenecks? The next thing we can then very easily get into is 5S, right? Sort, set, shine, standardize, and sustain. The tools are very, very basic. What are we talking about? This is workforce engagement now. This is at the line side, right? Operators, techs, those folks looking within their designated areas. What can they get out of there that doesn't belong there? What can they do to put whatever remains in a standard repeatable place, set things in place, and then start to clean the place up. Cleaning is inspection. In fact, the shine element, it leads to our next step, we'll talk about after this, is total productive maintenance. Have your workforce, your hourly, your cyclic workforce, operators, techs, start to see things that they can then forward to the maintenance to work on things that maybe is not in the schedule. Things that they see regularly, 5S gives them a structure in which to actually see those things. So sort, get things in that don't belong there, out of there. Set in place. The things that remain, put them in a standard location so they're always there, readily available. People have a common understanding of where those things are that they need to perform that particular operation. Clean the place up. Shine. Cleaning, again, is inspection. Standardize. So now that is repeated regularly, and sustaining it regularly verified that we're doing this. That's what 5S is about. And this is what we're showing in the tools boxes here on the right is, 5S. It is cleaning. It is the operators working ultimately, when we talk about TPM, hand in hand with maintenance on, hey, this is what I found when we were cleaning. Engaging that workforce. Remember the eighth waste that we were talking about? Once they see these things, they also have, probably the best to give us improvement ideas on the things that they find from the cleaning and the shining element. And doing it on a regular schedule. Right? This is what we're talking about. Sort, set in place, shine, standardize, keep doing it, sustain. The benefits from this, in our experience, right, aligns exactly with what we're showing here. These are immediate savings that we can find. Floor space, 60% opportunity. Forklift moves, because there's less stuff moving around. 45. Changeover times. Yes, there's definitely an impact on changeovers, which we will talk about as well. Inventory moves, physical inventory, 50%. Non-conformances, quality, back to quality. Huge opportunity, especially from the clean and the sustain elements when we talk about 5S. Workforce engagement, being in tune to their workplace. And who better to help us understand what's going on in those workplaces than our workforce? Give them areas that are natural boundaries that they're working within, right? Areas that they are trained to operate within so they can actually give us feedback on what they're learning from their 5S exercises, which does put the onus on the immediate supervision around the area to address some of those issues that are found. And again, a lot of these things, the 6 that we're talking about, you're going to start to see how they're very much integrated with each other. If we're talking about 5S and, cleaning is inspection and what they'll find and all these benefits that we saw on the previous slide that we can get from this, there's going to be some issues that we're going to need to resolve. And problem solving at the work group level, the most powerful use of problem solving. Why? Because those people are close to it. How they get closer? Well, they're working there every day. And if we're having them be engaged in 5S, making improvements, well, then we can also support them with effective problem solving. So kind of bleeding into, the steps that are yet to come. These things are definitely integrated, but they do start with some of the physical activities like 5S. Getting the place in order. Just some quick picture examples here where a place for everything and everything in its place, right? Just as my favorite of these pictures here, just like we would have in our kitchens at home, right? Again, we don't have a different spoon drawer every day, right? Our silverware goes in that drawer over there all the time. But why not in our workplace as well? For those tools, whatever they might be, whatever the operation is, place for everything, everything in its place, keeping it clean, looking for improvement opportunities. 5S helps us with that. We further help it with scheduled. Who's doing what, when, how they doing it, and tracking, ensuring that we're sustaining, right? Standardizing what the workplace looks like, how they operate that, and then sustaining it by ensuring that those steps are followed regularly and we are following up on what we find. You can use an assessment to see where you are, where you're going, how you're progressing. There's a lot of different ways to actually track what you're doing with 5S. It's a very basic, very straightforward way to actually find additional opportunities that we can then use to get to ultimately what we'd like to call visual, very visual factory, everything in its place, following and sustaining standards that support everything in its place, clean, and continually improving. This is what 5S can do for us. And it's within our control to reduce costs, especially the costs associated with downtime. One of the common elements that everyone has in any industry when we're talking about manufacturing is time. That's all we really have. And what are we doing with our time? Specifically with machinery and equipment, what are we doing to ensure that we're getting the planned capacity out of the equipment we've purchased, right? Total productive maintenance, the next lead in from 5S. From 5S. If 5S, gets us at the work, the operating, the hourly, the cyclic, the tech, workforce engagement, then support from maintenance integrated with that workforce to keep the machines up, running to quality, running to rate. Total productive maintenance is a cross-functional activity on the plant floor. It engages our workforce from the 5S efforts, shown here in the tool element, right? It engages our maintenance people and our maintenance system. Certainly our maintenance people, but the evolving system, the way we actually do maintenance, the frequencies, what are on the work tickets, right? Did we do the maintenance? Did we do it at its targeted time and its amount of allotted time? Was it effective maintenance, right? Total productive maintenance starts to integrate, yes, the 5S, yes, the maintenance experience, and the engineers. Here's our engineer over here to the right, right? This is what we're talking about. It's a cross-functional effort that actually is fed into from 5S efforts with one of the basic, there's a few basic measures around total productive maintenance. One being mean time to repair, which is one of the things we definitely have control over. Mean time to repair. Do we have the right tools in the right place, right skills, right people to do the effective maintenance according to schedule, according to the allotted time? Mean time to repair. Yes, it is driven definitely by some of the machine design, reliability, maintainability issues, which guess what? That's over on the engineering side. So maintenance working with engineering to first address, again, things that they can do immediately. What can we do to make machines more easy to maintain? Operators see this all the time, right? Get their engagement with it. Total productive maintenance, one of the most important elements of total productive maintenance is the use of hourly engineering, maintenance, and of course, even machine suppliers to continually look at how can we make machines more easily maintainable. Mean time to repair, the measure of how long it takes to actually, when a machine goes down, to get it back up, when it's down for maintenance, to get it back up. What are we doing to look at continually reducing those times? Again, time is money, right? So when the machines are down, what are we doing to get them back up as quickly as possible? Is there some redesign? Is there some, easily accessible tools that we might need on a particular machine? There's a lot of different things we can do. And how do we really incorporate that element into the overall effectiveness of the machine availability? Well, it's actually when we talk about the breakdown time or the up time as a percentage of OEE, which we'll talk about coming up. These things are all integrated. When we talk about 5S, when we talk about value stream mapping, yes, we are looking at one of the key things that we have control over: machine availability, machine uptime. How long does it take to get it back up and running when it's down? What can we do next after that to have the machines run longer? Mean time to repair, right? Or excuse me, mean time between failure. Mean time to repair, that's us. What can we do to get the machines up quickly? Meantime between failures, what can we do to make machines run longer between maintenance? So TPM, is it innovative? Well, perhaps in the sense that it takes into account, like I was saying, that triumvirate of maintenance, engineering, and the workforce, the techs, the operators, working together to see where can we make improvements in the quality of the machine when it's up and running, the time to repair the machine when it goes down, and ideas around how can we make the machines run longer in between maintenance requirements. It's not firefighting. It's not a short-term fix. It's not just maintenance. It is more integrated, and it is far more effective than just having the machines, and saw them cycle, fix them whether or not they need them, or how long did it take? Yeah, we just live with it. No, it is really a continual improvement effort focused on getting more uptime out of our installed capacity, right? So it is focused on quality. Even if the machines are up and running and they're not running to quality, well, guess what? We just wasted our time. We just ran the machine, bunch of cycles, it's not making quality. We lost time. Another measure of overall equipment effectiveness. So TPM, maintenance, with that triumvirate, maintenance people, engineering, and the operators. Operators focused on their equipment through 5S activities, connected to maintenance, engineering, connected to all of them, right? It is a cooperative cross-functional effort. Yes, there are all kinds of different techniques and, predictive tools that you can use. Yes, but using them effectively, right? This is why total productive maintenance from the people side really is the most high leverage element of TPM. All the technical elements around maintaining equipment, they're going to be unique to pieces of equipment anyway. Are you working on the right thing? Are you working towards the machines when they're up? Are they running at quality? And you're keeping them running with short time to repair and long time between failure. This is what TPM will focus the team on, right? And so it's really an element with, total productive maintenance. It does have still reactive elements to it, definitely planned elements to it, and certainly some predictive technologies with it as well. It's a combination of these things with the goal to start to reduce the reactive more into the plant, and the plan that is adaptive as the teams make improvements along the way, and start to reduce those issues and eliminate those frequent downtime causes. Yeah, that's stuff they work on. And they work on that with problem solving, which again, we'll get to a little bit later. So it is collecting data. It is looking in the end goal, the vision of, yes, maintenance-free design. Well, who develops maintenance-free design? Well, that'd be the engineering effort, right? Again, cross-functional. Using data coming from where? Well, 5S can help collect that data. I know there's a lot of machine monitoring systems out there. And of course, use that data. Omnex does have an integrated tool to help track those and watch improvements as improvements are being made in meantime between fails and meantime to repair. Certainly, the goal is more uptime, total productive maintenance, cross-functional effort using whatever technologies are needed with the goal of improving uptime. Yeah, so all these elements actually go into plan, predictive, even, yeah, there's still breakdown in there. The goal to reduce that to zero. That's the goal, right? And then leading in, of course, to preventive, corrective for making improvements. Improvements based on opportunities, problem solving, right? And then can we prevent maintenance by, again, improved designs? Information being fed up and fed into the improvement efforts for improving machine design, improving maintenance. That's what we call total productive maintenance. That's where it comes from. So here too, part of it is cleaning is inspection. This is what we talk about. Where does this come from? 5S at least, right? Getting rid of that grime. So we can see things, and we can see things that are abnormalities, things that, hey, never saw that before. What's that coming from? If there's close, tighter relations, let's say, among operators and maintenance, things that are found when you're getting rid of grime and cleaning things up can be addressed quickly. If you're not, where are these, shavings coming from? Where those can help, right? Developing some standards around the way maintenance is done, standards around cleaning, lubricating, putting schedules together, work tickets that are evolving, but are standard as they improve, right? Skills, right? That you are going to be improving for everyone across the board, back to workforce engagement, right? Workforce engagement. So people can see things, so they can actually act on things. Another element too of total productive maintenance, which goes back to the work group engagement, autonomous actions by, once again, our techs, our operators. What we have found is that as 5S matures, our operators become far more comfortable in the things they're seeing and in what they believe are some things that they can address from a maintainability standpoint in their operation, and actually offload some of the work from the maintenance people, something we call autonomous, not just inspections, that's the first start, but some autonomous maintenance, things that operators can do within cycle to maintain equipment that doesn't require a call for maintenance to come, line get shut down for that whole activity to occur. It starts to really feed on itself and starts to make far more higher quality, regularly, scheduled maintenance actually goes down. And what happens is machines are up more. There's more uptime, right? Visual maintenance. Yeah, can we actually start to make the machines more visually observable when maintenance is coming due, right? Actually, can we take, oil bottles and have them out visual so we can see oil levels, gauges on things, so we can see how equipment is actually running before a potential failure mode comes out, right? And again, consistently using autonomous maintenance, workforce engagement, measuring that ultimately with OEE. How much time is equipment up versus what it was supposed to be or planned to be? Whoops, right? It's a lead into this whole discussion of OEE. Cycle time. Maintenance on the equipment includes making sure the equipment is well enough so it's actually running at cycle. It's running at cycle, not lost speed or lost part count because machines are running slower than planned. And of course, the quality yield of the whole thing. What is scrap, rework, the hidden factory piece as well, startup losses, those kinds of things. That's what we're talking about that gets impacted by 5S, total productive maintenance, and the use of, to this point, again, value stream mapping to be able to see where the constraints are so we focus our attention on the priorities. How do you measure this? Yeah, OEE, give me data, right? Give me data. The equipment availability, quality rate, efficiency. That's what it's about. Percentages. Multiply those things across each other. Track it over time as you are continuing to make improvements. These are the big losses that we saw from the 7+1. This is where it manifests itself. The availability of the equipment, uptime, mean time to repairs, things we just talked about. The quality rates. Are you making quality when you're up and running? And of course, then the efficiency. Are you running at rate? Are you running at rate? And what are you doing about these things? What are you going to look at? Breakdown, setup times. Setup, those are downtime losses. We're going to talk about those next when we talk about quick change. All right. Losses. It's all comes down to time. All right. So what do we look at? Breakdown, setups, idling, speed losses, right? For the productivity time. Overall effectiveness is the compounding of these three elements. This is why we, start talking about OEE. It's, OEE in the past, I know people, I'll be very frank, they've tried to trick it. Yeah, we'll just put, where are we measuring this? That kind of thing. Well, look, if you're under the pressure of tariffs, you've got to reduce your costs. I know firsthand, working with several of you first, second, and third tiers out there, that the pressure is on from your OEMs for you to get additional costs out, additional on top of what you already had as targets, right? Okay. Don't trick OEE. I've talked to groups like, oh, yeah, well, we know how to trick it. But why? No, you got to get your costs down. These are the base elements driven by those 7 wastes, identified by all those contributory costs. Here's where we're focusing our efforts on. Get the machines up and running at quality and running at rate. There's nothing more fundamental. We talk about labor and overhead. You have to make a certain number of parts every day to pay for your labor. If you don't make those, you just lost money. These are the base measures for those. So when we talk about uptime, the drivers for that, yeah, maintenance, the wellness of the equipment, including the measurement systems, although we're not going to talk about measurement systems today, but on the equipment itself, up and running at quality, running at rate. How? Cross-functional participation from your operators, maintenance people, engineering, to make continual improvements focused on the high priority constraint operations identified by your value stream maps. This is how this stuff all ties together. The maps show us where to go. 5S helps us start to clean the place up, start to see things, starts to make those connections among maintenance people and engineering. Total productive maintenance brings it all together to focus on quality, uptime, and throughput, cycle time. Team effort. These are all within our grasps. So when we talk about OEE, it is value stream mapping, it is 5S, it is total productive maintenance. Today we're just talking about scratching the surface on these things, but they're within our grasp. These are things that we can do, and for most of the part, we are doing it, right? Quick changeovers is the next thing we get into. Well, where's another place where we lose time? Changing over equipment. And as we're talking about tariffs, and I've seen production schedules swing wildly over my time when I was at work at Ford Motor Company. Now it's even crazier. I've seen shifts in production, machines up, down, changing over. How are we on changeover? This is another factor of lost time. Are we good at changeover? So we talk about quick change and, if you will, the basal element of time. It's another area for us to look at. When we talk about just looking at our quick tool, review here on the right, yeah, this is the way downtime, traditionally is done. There's some external, yeah, we do some stuff. There's some internal. External is we can do it with the machine up and running. There's some internal. However, we traditionally, machine goes down, has to go down. And then there's some more external, maybe cleanup, getting things back up and running. What can we do to reduce the prep, the actual time when the machine is down, and then when we have to get it back up and running again. Do we study these things, or do we just say, that's how long it takes to do that. It's always taking that long. You can't turn the machine off until, this point in time. And okay, really? Is that true? What we talk about with quick changeover now, the focus is on what are we doing to be able to quickly get machines back up and running once they've been changed or need to be changed over for whatever reason. Quality issues, tool changes, production schedule changes, whatever we need to do to be, you can use the term nimble, but it's more importantly, what are we doing to get that machine back up and running? When you buy a machine, you made some assumptions on how much of time it was going to be available. That's going to drive your capacity planning. Well, what are you doing to ensure that you're at least meeting those capacity plans, taking into account the changeover times? And what are you doing to make improvements in it? This is what we start to now focus on. What are we doing on getting the machine back up and running? What are the wastes in getting machines back up and running? Take a look and see. Are people waiting around for the machine to go down before they do something? Those folks could be employed doing other things. What are they doing to ensure that the time they need to set up to take a machine down, are there opportunities in that time? Look at the actual internal time with the equipment. Is there something that you can do to maybe do some more things external, right? Look at when do you actually have to, when does the machine absolutely positively have to be down? How much stuff can you do that maybe you didn't consider something you could do in parallel? That's another way I like to look at it. Machine's still running. What else can you do that was perhaps considered an internal thing you can't do until the machine is down? But hey, maybe there are a few things that we can do. Can we pull those out? Can we shut the machine down sooner by doing some things earlier? Pull those things out, right? The idea is very short example from here to here, right? So we can get back into production as quickly as possible. Looking at step by step, what do we do to get a machine ready to change over? And looking at simple things in prep. Can we get the tools that we need close to the equipment before we actually shut it down? Can we pull some things that we thought we had to have the machine down for? Can we pull those into the prep work? How about on the startup side? What do we need on the startup side? Maybe we need to have additional parts sitting there ready to go. No waiting. Single minute exchange of die really gets at this idea of, wow, can we get it down to a couple minutes, single digit minutes to change over a piece of equipment and less, right? Continual improvement on that. Looking at the internal, can we pull some of those things that we thought were only when the machine was down? Can we pull some of those things out before and do them then? External is everything we can do, when the machines are still up and running. So a way to look at that, a couple phases. Yeah, look at the external, look at the internal. What can we do, to shorten the time for the external prep, pull things out that we thought we couldn't do, but maybe we can. And then look at the run or the setup time and then the startup times. What can we do? Can we do things in parallel? Can we start to convert internals to externals? Can we do things in parallel on the external side, right? Walk the process. Walk the process being your changeover process. What can we do to address these things? Put things in parallel, take things that we thought we could only do with the machine running or not running to when they are running. What can we do to reduce those times? It all, again, comes down to time. What's it do for us? Makes us more flexible, right? For quality, safe management of tools, right? More production. And to help us with a lot of this, finally, problem solving, being effective problem solvers, using 8D as a problem solving tool, not as a form. Using it as a problem solving tool, not as a form. And any other tools within there to help see the problem, have our cross-functional teams on problem solving be able to get to those particular causes, root cause using 5Y, right? As example, 8D, short-term cross-functional teams. Focus on those 8 steps, form a team, get the problem identified, described, interim containment action, root cause, put it in the permanent corrective action, implement, prevent, congratulate the team. Within this problem solving, sure, 5Y. What groups can do this? Operators can do this. Techs can use 5Y. Ask the question why 5 times. Most powerful, easily accessible, maybe needs a little bit of facilitation. Get people 5Y. Ask the question why. At least get past the third Y. Go as many Ys as you need to. Verify along the way. 3x5. How did it get out of here? How did we actually make it? And then stepping back and looking at the way we did work. How do we allow the probability of the occurrence to occur? And then how do we let it get out? 5Y, super powerful. At the top of the pyramid, sure. DMAIC, Six Sigma thinking. Define, measure, analyze, improve, control. Same thinking. Give me as a D, it's a logical process. Reducing the defects, however you're defining a defect. Certainly you can focus on quality, but getting to the root causes, that thinking of Y is a function of a series of X's, understanding those processes that you're looking at to drive to the root cause of what's going on and how potentially more than one cause is addressing your big measurable, your parts per million, however you're measuring that. Using some statistics, more importantly, at the work group level, being able to ask the 5 W's and the 2 H's as part of even leading into 5Y questioning. Who's having the problem? What is the problem? When, where, and why? Why? How big is it? And failure mode, do we know how it happened? Yeah, you can use statistics for that. Sure. Measurement systems, just to touch on it, are they capable? Are we, within the capability of our system? Are our measurement systems capable? Talking about gauge R&Rs, right? Use any kind of graphical tool you can, even in 5Y use. Cause and effect diagram, we've seen it a few times now, but there's a lot of different ways, including, process mapping, a little bit slightly different view of value stream mapping. Give us the data so we can be effective problem solvers. This is really what we're talking about when we're saying, look, if you're going to be developing a process map, a value stream map, and you're collecting data, well, let's see trends. Let's see some other, indications of what could lead us to potential root causes, right? Let's use 5S to start to actually see our operations. These are things we can do with all the benefits we saw. 5S to start to see. Tagging now into total productive maintenance, getting the maintenance and engineering to help us with essentially making continual improvements, one of which we touched on with the metric OEE, changeovers. Track this stuff. Focus in on this. So then you can actually get into problem solving and being effective problem solvers. These things all go hand in glove together. That's why we were talking at Omnex, we were saying, okay, what do we really want to do to help with this whole tariff situation? Well, our first discussion was around, well, we got to get control over things that we've got control over. So what do we have control over? The things that we're talking about today. What are we focusing on? The wastes. What do we do with some tools? Well, here they are. 5S, simple tool. OE, great metric. Total productive maintenance. Yeah, we can do that. Great lead in. Quick changeovers. Yeah, we can do that. How about effective problem solving? Yes, we can do that. And we can do that with a variety of different analytical tools perhaps you already have. Right? I'm just kind of walking through some of the Six Sigma items. Whatever tools you have, put them to use. One of which then you got to think about is, okay, once you start leading towards putting in improved practices and standards, locking in those improvements, use your existing control documents, failure modes and effect analyses, process flow diagrams, control plans, work instructions. These are the tools, our operational tools that will help drive the behavior of our workforce, addressing the cultural elements to now start to actually practice. Remember, even in 5S, we talked about sustain. Yeah, have some work instructions for what are we cleaning, when are we cleaning, who's cleaning what, how do you clean it? Have work instructions. Use existing control documents that you have to lock in your improvements. All right. Mistake proof, visual controls, physical controls, helpful. Operational controls, absolutely important. That's what we're talking about here. All right. So yeah, a couple elements of control gets us to here. Standardizing practices, commonizing, simplify your operations, commonize them, codify them. Well, what is that? The documents we're just talking about. Make those things standards. So when we're talking about our path, like we saw at the very beginning here, was get some metrics. What are your goals? Make those metrics actionable. Value stream map. What are you going to improve? Go see. Define your current state. Know what to improve? Yeah. Engage your teams. Have the value stream maps lead you to those discussions. Engage your teams. 5S, like we're talking about. Leading into continued improvement, surround maintenance, things to get the time out of your lost time. Make those improvements, right? Standardize that practice right there, that cycle. Standardize that practice and update your control documents for the actual improvements you make for everyone else to follow. This is how we do it. And so we're talking, what we actually like to call this is what we call our optimal approach. What we have found when we take this approach and do our classes, our on-floor implementations, consulting, and continual coaching out of Omix, we see a return on investment from our efforts with you threefold. You know, we work on projects at simply $35,000 for very minor things, up to $1.5 million on things that are a little less minor. The payback is what we are thinking about it on the optimal approach. It's about operations and production training, integrating that learning in embedded workshops. That's what we do when we come out there. It is focused on the manufacturing system, using value stream maps, using 5S, things we talked about, applying the learning specifically to focused improvement efforts and leveraging that across line 1, line 2, machine 1, machine last, including operations on the cultural elements to maintain those through standard practices and then looking for the next improvement. This is what we're talking about. So when we say, you know, here are the steps, right? Value stream mapping, 5S, total productive maintenance, looking at overall equipment effectiveness, using those and quick change techniques with effective problem solving, that'll get you up the curve. And where we're saying, look, Omix, we can be very helpful for that. So please, you know, reach out to us. I know a lot of you already know us from some of the things that we do with y'all. Take a look. You can do these things. And if you need our help, you can reach us. You know where to reach us. Let me just say this real quick. This is what we're talking about today. These. And that's where I'll leave it. So, appreciate your time here today. And I see there are a few questions here. John, if you're still online, are there any industry tools to create an interactive dynamic model of the manufacturing process executable and incorporates the concepts in your presentation? Yeah, there are some discrete event simulation tools that you can apply some of the data that you would gather from the value stream mapping exercise. First step, value stream map, take a picture visually of what you're doing. Walk the system from back end to front, collect those pieces of information, operation by operation. What's the work in process inventory in between operations? What's the cycle time of the individual operations? Downtime, you know, time it takes to change over, those kinds of things. Quality rate losses. Get those collected first. Do not get too engaged in when you're creating a value stream map, which is the first step. It's data collection. Use data maybe you're already collecting from real-time data acquisition systems. That's great. Put it into a more visual, condensed form the value stream map provides for us so that you can start to really see where your constraints are. Compare the non-value at a time, which are basically the times where parts are waiting in inventory in between operations versus the actual cycle time for operation to operation. 10 seconds for app 20, 10 seconds for app 30, that's 20 seconds. Okay. Versus parts are sitting there as a part. Maybe they sit there for 2 hours before they actually get processed, right? Find those constraints based on that kind of metric. And then, yeah, you can start to pour those into, there are some discrete event software simulation packages out there that you can start to do like Monte Carlo methods to get more of a statistical distribution on what your throughputs would be. So yeah, there are some tools out there that are more software based. These basic ones we're talking today are definitely physical and operational. Right? So what are the effects of tariffs on just-in-time delivery? Yeah, the effects of tariffs on just-in-time delivery is the supply shortages to your plant, where you're getting your raw materials, or if you know the parts that you receive on bailments or whatever. The impacts there are supply shortages. Period. Things are going to dry up, and so somewhat that's one of the things I think I pointed out in the earlier things are kind of out of our control. For internally, what that means is um, for just in time, we'll be looking at our changeovers. Are we really good at changeovers? Because what's going to happen, I believe, and actually seeing some of it, is there's going to be a move towards products that are made in the near term, more in the US. And so maybe those are products that are not the high runners right now. And so we'll be changing over to maybe some product lines that we haven't seen for a while. There's going to be a change in product mix is what I'm getting at. And so that mix, are we ready internally to quickly change over as that mix is going to be changing? It's going to be in a state of flux, I believe, for the foreseeable future until there's some settling in on what the actual tariff numbers are going to be on things that, because product planners are trying to figure out what should we make right now. And plants are being shut down because they're saying, well, we're not going to bring those parts in. So what are they going to backfill that with? Higher production of other parts. So the other piece on just in time, maybe there'll be higher runs on your number one runners right now. Okay, so what is the mean time between fails and the mean time to repair of the equipment that's making those already high volume parts, right? You're going to be asking more capacity out of those machines, those lines, those people. So you're going to be looking at getting more machine uptime from those things. And that's going to be meantime. The first thing is always that we have in control is our mean time to repair. What are we doing to get the machines up and running as quickly as possible when they do go down? And what then are we doing to ensuring that the machines run as long as possible at quality? The worst time impact is if we're not making quality. Because that's the machines running, they made a bad part, and now we got to make another one to make up for that. And we have to make up for the one that we had to make up for that one. Compounds. So running it right at quality. That's the other impact for just in time. So yeah, John, again, another question. Yeah. How does lessons learned fit in? Well, yeah, lessons learned is something that we would feed into you need a mechanism for this too. Lessons learned are essentially what comes out of the continual improvement efforts by the teams. So the question would be, yeah, you can put them in a lessons learned database. That's nice. How about doing this? Baking in the lessons learned, the changes you've made to improve your throughput, your capacity through continual improvement projects that we're talking about here. How about you bake those into those control documents we were talking about? Go back to your failure modes and effect analyses, update those feed process flow diagrams, update those. Update your control plans, update your work instructions. That's where, in our experience, where we actually take the lessons learned and you put them into your daily control plan. That's where you really get the benefit from learning, right? Yes, I know a lot of places have lessons learned databases, and that's great. But when we were in production, I always wanted to ensure that we're actually applying those lessons either in the physical hardware or in the operational practices. Where do you do that? Well, in the physical hardware, okay, we kind of get that. It's in the physical hardware. In the operational practices, the cultural element, it's in those control plans, right? PFMEAs. Let's just start at let's just go to the process, not into the design, but let's just process FMEAs, process flow diagrams. Where's all the knowledge we have today captured? Process FMEAs, process flow diagrams, control plans, work instructions. That's where the learning really gets applied and leveraged into our manufacturing systems. That's where I say that's how lessons learned is really baked in there. And Bill, yeah, I'll give you a call. Okay. So we've gone over our allotted time a few minutes. Kelsey or Andrew, if you're still here, if you wanted to make any comments on closeout, I think that's all I have for right now. Just asking the participants, feel free to get a hold of us for any kind of training, implementation, coaching, consulting along any of these elements. We're here to help.
Yeah, thanks, Mike. Thank you everyone for joining today's webinar. We hope to see you at our future webinars, and we wish you a great rest of your day. Thanks.
Thanks, everyone.